Hi, and welcome to Common Core Algebra II again. It's 6.1 quadratic functions. So Unit 6 basically is going to be dealing with a lot of quadratic functions, and a lot of this, especially at the beginning, is review from Common Core Algebra 1. So the first few lessons should be crazy easy for you, and we should be able to get through the videos rather quickly. All right, so please make sure you understand what a quadratic function looks like. So any function in the form f of x, this is where I am right here, f of x equals ax squared plus bx plus c, where the leading coefficient a is not 0. Because if a was not 0, we'd have bx plus c, which is basically a linear function. All right, so this is the form. A, b, and c are going to be coefficients. C is your constant, my apologies. A and b are coefficients of the quadratic. We call this the quadratic term. We call this the linear term. And we call this one the constant. So you can write that down here. This is the quadratic, this is the linear, and this is the constant. So exercise 1 says without the use of your calculator, but once again, you're always going to have your calculator. So I just want you to do a little bit of thinking. And it says evaluate each of the following quadratic functions for the specified input values, recording that according to the formal order of operations, PEMDAS, which we like to call it, exponent evaluation should always come first. So here we have function notation. So all we're going to do here is wherever there's an x, we're going to substitute in our x, which is -3. Notice how I put it into parentheses, so that way we know that -3 is actually -3 times -3, which is a +9. And 5 squared, when you have a positive number, it's pretty easy just to do the math in your head. So moving on to B, we have 2 times 2 squared minus 5. Now, like I said, you can put this right into your calculator using the parentheses exactly the way it looks, but in this case they asked you not to use your calculator, so this is simply going to be 2 times 4 minus 5, which is 8 minus 5, which is +3. And the last one is -1, so it's 2 times -1 squared minus 5. You don't have to do each step the way I'm doing, but I want you to make sure that you're not making mistakes, because that -1 squared is a +1, so 2 times 1 is 2, minus 5 is a -3. And remember what that means. That means on this quadratic, on this function, g of x, basically, my x value is -1, my y value is -3. That's my point that sits on that function. So we have h of x is equal to -x squared. Now remember, that negative out front basically is done after the exponent here. So this becomes -2 squared plus 4 times -2. So this becomes -4 plus 4 times -2, which is -4 minus 8, which is -12. And that h of 3 is -3 squared plus 4 times 3. And I encourage you, especially on any kind of exam, that you do use your calculator, because we do tend to make mistakes with these negative numbers. So this becomes -9 plus 12, which is equal to +3. Right, so that should have been pretty easy for you. Nothing new here, just function notation and evaluating. So, graphs of quadratic functions form what is known as parabolas. The simplest quadratic function, the one that you should be very familiar with, is reviewed in this exercise. So, we're going to consider the simplest of all quadratic functions, which is called the parent function, y equals x squared, because all other parabolas kind of stem from that. So A says create a table of values to plot this function over the domain interval between -3 and +3. So I left the table here for you to fill out, and you should be able to do this pretty easily. just like we did in exercise number 1, we're just going to substitute in. So when we substitute in, negative 3 squared is positive 9. Negative 2 squared is positive 4. I'm sorry, my board is kind of acting weird here. All right, negative 1 squared is 1. 0 squared is 0. 1 squared is 1, 4, and 9. And thinking about that parabola, I'm going to remind you that that symmetry that we're looking for, the symmetry that's right here in the middle, because remember, this is the symmetry I'm looking at. This tells me what my vertex is. This is my vertex, or also known as the turning point. I'm getting a little ahead of myself, but sketch the graph. So let's just start. I like to always start here. And I do one side of a parabola, 1, 1, 2, 4, 5, 6, 7, 8, 9. And I know my other side should look pretty identical to that right here. Notice that I have 1 point on each one of the vertical lines. All right, so that's something that you can make sense of, because sometimes what happens is people by accident will miss one, and they might put one here by accident. And then when they draw it, they'll see that it does not look symmetric. So beware of that. So what we're going to do here is we're going to start over here, and you start here. You're going to go down. You're going to make sure that you're hitting all of those points. I don't know if I can get rid of this, but I'm going to try. There we go. All right, I always label y equals x squared. Always, always, because who knows, you could get points taken off if you don't label. So we sketched it, we took care of B. C says state the coordinates of the vertex. Now we just looked at that. You can see it on the graph right here as the turning point. So I know that vertex is 0, 0. But like I said before, we can also see it on the table. And sometimes looking at the table, especially on our calculator, is really helpful. Okay, and we're moving state the equation of the axis of symmetry. The axis of symmetry is going to be this line that sits right here, right through the middle of the parabola. In other words, if I could fold it one on top of the other, I would have that line. And the equation of an axis of symmetry is always going to be x equals a number. And in this case, x equals 0, because it crosses the x-axis at 0. So x equals 0. I just want to take a minute to remind you that the formula for the axis of symmetry is x equals negative b over 2a. Now, in our example of x equals, y equals x squared, the only thing I have here is my x squared, my a, which is 1. So x is equal to 0, because b is 0, over 2 times 1, which is 0. So that's another way that you can find your axis of symmetry. And it asks, over what interval is this function increasing? Well, it's increasing from 0 on. So I know that interval means x values. X has to be greater than, not equal to, because actually at 0, it's not increasing, nor is it decreasing. So I'm going to say x is greater than 0 is my interval. So that should have been a piece of cake for you. So write down what you need to, and we'll move on. So all quadratic functions that have unlimited domains, which are domains that consist of the set of all real numbers, have turning points and an axis of symmetry. It is important to be able to sketch a parabola using your graphing calculator to generate a table of values. So in exercise 3, it says consider the quadratic function. Again, I always like to put a box around my important math information. All right, and it says using a table on your graphing calculator, determine the turning point of this function. So very easily, we can open our calculator. We're going to go to our graphing icon, and we're going to put this in. So negative x squared plus 6x plus 5. the first thing I always do is I double check that I have it in exactly the way it is on my paper, which it is. Now I hit enter. So this is what it looks like. And as I can see on this, it's not giving me very nice roots. They're not integer roots, but that's okay. I don't know if they're asking me for roots here. But what they are asking us to do is generate a table. So what we can do is do Control T and bring up the table. And the one thing I like to do when I'm doing a parabola is I want to look for that symmetry we just talked about. So I'm going to head up a little bit and I'm going to look for that symmetry. Did I find it? Oh, I did already. Look. I can see here that I have 13, 13. Now, if I head up one, I probably, no, I'm sorry, I have to go down one. Oh, I head down a little bit, I can probably see how, again, I have symmetry here and here. I have symmetry here and here. And if I look one more time, which I really can't here, I would have symmetry again here and here. All right? And this point that's right in the middle is my turning point or my vertex. That's really important information. So let's take a minute and let's write this information down on a table. So now you would go back to your paper and you would write down your table wherever you can possibly find room. X, Y. I'm going to start with 0, 1, 2, 3, 4, 5, 6, and it's 5, 10, 13, 14, 13, 10, and 5. So let's actually graph these now. So we have 0, 5. Here's my X and here's my Y. So 0, 5, 1, 2, 3, 4, 5 is here. 1, 10, 6, 7, 8, 9, 10. The next one is 13, 10, 11, 12, 13. Then up to 14, that should be 3. And then we come back down again, over 1, down, over 1, down. And I always tell my students, whatever points fit on here, make sure you are graphing. So if you look on your graph and you go to 7, you can see 7 would be on your table to -2. So I would make sure 7, -2 would be down here, which means -2 would be down here. I include every point that fits on the graph that they give me. So we're going to go up, making sure we're hitting those points. Don't skip any of them. And there we go. And again, I always give it a label. Y equals -x squared plus 6x plus 5. Anytime we get graphing problems on a Regents exam, it's a bonus because we can use our calculators. So we did A. B says, what is the range of this quadratic? Well, range are our Y values. So basically, if you look right here at this line, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, we should have gotten that from the table, silly. Right here. My turning point is 14. So what is the range? Y has to be less than 14. Oh, I'm sorry, it can equal 14. Graph this function on the grid to the right. I did that already. Why does this parabola open downward as opposed to y equals x squared, which opened upward? Well, what's the difference between this one and the first one that we did? Well, I'm hoping you're realizing that our leading coefficient in there, leading coefficient is negative. And that means that it opens down. When you have a leading coefficient that's positive, it opens up. Between what two consecutive integers does the largest solution to the equation -x squared plus 6x plus 5 equals 0 lie? Show this on your graph. Well, they're looking for the 0. So they're looking for this point right here, and they're saying the larger one. So 1, 2, 3, 4, 5, 6. So it falls between 6 and 7. But if we can actually find the exact point of intersection using our calculator, I'd like to take a minute to show you that. Because on our calculator, I'm just going to get rid of this table by hitting Control T, get rid of the calculator table. And what you can do is you can go to the menu and you can do Analyze Graph right here at number 6. And you can go to number 1, which is 0. And you see how you have this line here? You can use your mouse to, and I don't think I can use my mouse here. I have to use my side button. But I'm going to use the first one, move it over, just to the left of it, and hit Enter. And now I'm going to move it over again, if I can find it. And it gives me another line. And as long as I'm incorporating that 0 into it, it gives it to me. It's right there. So the answer is 6.74 is the actual 0 that we can write down if they asked us for it. All right, so we're going to do some practicing about that in our class tomorrow. Okay, so let's go back to our problem. It doesn't ask, it just asks between what consecutive integers, and that's 6 and 7. All right, exercise 4. Last one. The sketch of the quadratic function right here is shown below, marked with points at the intercepts and its turning point. Using the tables or graph on your calculator to determine the coordinates for each of the points. So we're going to pull up our calculator with the information. Okay, but before that, let's figure out what they want us to find. They want us to find the x-intercepts for A and B. So they want us to find this point and this point, the y-intercept, which is D, which is this point, and then the turning point down here, which is C. So let's go to our calculator and see what we can do. So as you can see, we can only see part of the parabola on our graph, but I can tell you that we're looking for that A point, and that A point is the negative side. It's over here, and you can see pretty clearly right here how that is going to be -2. And then we can double check that by looking in our calculator at -2. All right, and then the other point, which we can't see so easily on our graph, we're just going to head down until we find y is equal to 0 again, and there it is right there at 13. Where did it go? There it is. So we have the other point being 13, 0. So let's take a minute, write those two down. A, we just said, was -2, 0, and B, we said, was 13, 0. Found them right off of our calculator. The y-intercept, pretty easy with this. If you take a look right here, just like in y equals mx plus b, right here is going to be our y-intercept. So our y-intercept is going to be -26, 0. And we can double check that also on our calculator if we just keep going down and we get to, I'm sorry, we have -26. My bad. We have to go the other way. I'm sorry, I have to do this and it takes so long because I can't do it faster than this using my mouse. Oh, sugar plums. I'm not even paying attention. I'm looking for when x is 0, so I passed it. And it is right there, 0, -26. Now the vertex, again, that's what I'm talking about. The vertex is something that we can't see. So there's a couple of things we can do here. Control T takes away my table. And then we can zoom out of this a little bit. So go to zoom, and I want to zoom out. Come on, move over. Zoom out. So now I'm just going to keep hitting the enter button until I can find that vertex. And there it is right there. All right? I know it's kind of hard to see it, but I need to leave a little bit of space in there. Menu, I'm going to analyze it, which is 6 at 0. Again, I have those lines there. So I'm okay with that one there. I'm going to slide this one over. And I'm going to make sure I incorporate. Okay, board is resetting. And we're going to make sure we incorporate that 0, and so there it comes, 13, comma 0. Well, that's a 0. No, it's asking for our, oh, it doesn't ask us for the 0. My bad. We already had that at 13. What we want is the analyze. It's a minimum value right there. So we're okay with leaving that one there. Now we're going to slide this over, minimum. And there, you're going to make sure you get all the way over there. And the answer is right there, 5.5 and 56.3. Okay, so that's how you can do it in your calculator. Going back here, so my vertex is 5.5 comma 56.25, or 0.3 as the calculator said, and says over what interval is this function positive? So what x values, that's what they're saying, right? So basically what this means is what x values yield positive y values. Flipping that question sometimes helps. So if we take a look at this, we know that x has to be less than -2 or x has to be greater than positive 13. Okay, so I'm sorry these videos are taking a little longer than they used to. I feel like I'm trying to make too many points, but not too bad, 21 minutes. And again, I think you should be able to fly through this work tomorrow before we move on to 6.2. All right, so until then, be kind to one another, make good choices, and I'll see you next time.